Yes. So hi everyone, I'm Dheeraj and today I'm gonna talk about TII interview guidance program. Okay, so I will be talking about many things here, not only the Texas Instrument India, how you have to crack the interview. Okay, prior to that, what you have to do exactly, right? So I have been guiding for this program from past couple of years. Okay, and I've been also guiding for GATE and IES aspirant from the past many years, around 5 to 6 years. Okay, and I'm associated with various institutes as a full time as well as contributing my expertise in analog circuit as well as electronic devices. Okay, and communication and EMFT. So I started some YouTube channel and there I got some responses from when I uploaded this video on this TII. So I got many response from many students. So they contacted me directly. So I took their interview as well, right? So they got selected as a full time in TII, okay, Texas Instrument India, as well as they got intern as well, right? And so today I will be talking about various things, right? So let me, yeah. So this session is for electrical engineering, for electronics and communication, as well as instrumentation, right? Who all are interested in analog circuit as analog circuit design and digital, or you can say the VLSI part, right? So today the session will be on the outline of the session will be the online test. Okay, the very first step will be when the Texas Instrument India will be visiting to your college, and if you are in BTech or MTech, right? So the very first step is gonna be the online test. They will be conducting some online test. Okay, though they did not specify the particular syllabus, but you know but as you can go through on the Google, you will find many people have shared their experiences. Okay, so you will find what they ask, and in fact you can also get some sample paper, but I will be talking about how to prepare for them, and okay, and what kind of motivation you want and what are other ways. Suppose TII is not visiting to your college, then what are other ways to get into Texas Instrument India, right? So, my motivation was when I uploaded that video, so that was just other way of getting into. Okay, so that thing also I will discuss today. Okay. Yes, so next I will be talking about and in fact emphasize on interview, because online test, if somebody is preparing for GATE or yes, Gaurav Agrawal is saying, yes. Okay, so Gaurav Agrawal, what he's saying, he has some online exam. Okay, so yeah, you can speak also, Gaurav, right? Let me start first, then you can, unmute your, then you can ask directly. Yes. So we will be talking about that. Yeah. So the next part will be what are the ways to get into TII, right? I will be talking about Texas Instrument India, okay, because I'm in Bangalore only. So, and I also have guided for India. I mean, for the company which is here only, okay. For okay, so I will give you many example as well who have got selected. Okay, yeah. So the online test, the very first step is gonna be online test. Okay, so for any company, if that company is visiting, right? So you must first go through about that company, right? Suppose you are in electronics and communication, or you are studying in electrical engineering, and definitely you will hear some voice like what is analog, digital, profile, analog profile, all these things. So uh, when these company visited, so they will be conducting first the online test. So but before attending these online tests, I would suggest that you must go through about Texas Instrument India regarding that company, right? So what they are offering by typing career at the rate Texas Instrument, right? So you will find all the information. So any company if they are visiting, so you need to type in a Google career at the rate that, right? And the profile you are looking for, so you can go through all those things, right? Yeah. So in the online test, the very first thing will be the aptitude, right? So the question now here is what kind of question they will be asking. So aptitude means aptitude, right? So any topic can be asked. Okay, if you are preparing for GATE, so you might be familiar with various topics are there. In fact, the topic which are being asked in CAT examination. Okay, there are various topics. Okay, so those topics will be asked only. Okay, like percentage and permutation and combination, right? I will choose pen as well here so that you I can highlight. Yeah, so the very first in the online test there will be aptitude. So in the aptitude, yeah, number of question also varies, right? So aptitude, various topics are there, like such as mainly the questions will be asked from percentage and probability. Okay, and you can say percentage, profit and loss, all those things, right? And then yeah then the yeah then the analog will be the next okay topic of interest, where they will focus on various electrical circuits. Right now you might be in your BTech, and there are various name of this subject, right? Basics of electrical circuits, such as network theory, okay, which is in gate examination syllabus as well, and sometimes it is also known as circuit theory, right? Okay, so but in that they will be only focusing on few topics which I will be discussing. Okay, and the next topic is gonna be the op-amp. Op-amp, everyone might have heard about op-amp. Op-amp is one of the very versatile structure. Okay, okay, and nowadays in all the analog industries, everything is modeled with the help of op-amp. Everything is implemented with the help of op-amp, right? So in fact, this is one of the very important topic, right? So you must be good at that op-amp, okay? And today I will be talking about how you have to look at the op-amp. See, you know the op-amp, you know basic electrical circuits, everything you know, but how to solve the problem, okay? In the way the problem should be solved, that those things I will be discussing today. And now after this season, if in future anything will be required, I would be assisting as well. And this guys, everyone knows MOSFET, right? This is one of the very great device. Okay, related to this question will be asked. Yeah, and etc I have written. Okay, so there are various devices such as diode. They will couple diode with op-amp. Yeah, let me yeah. So op-amp plus diode, they might okay add, and they can connect op-amp plus BJT as well, right? Bipolar junction transistor, they might connect op-amp plus MOSFET. So the question will be of that kind. Okay, so we will talk about those few questions as well. Next will be the here you can see the next is gonna be the digital. Okay, so if they are coming for digital profile and you are interested in digital profile, so there are various kind of topics. Okay, we basically focus on basic gates, combination circuits, okay, and sequential circuits, basic circuits, right? But we do not focus on the very important topics. Okay, in fact many educator are also many professors also, they skip in their college some of the very important topics, such as delay in combinational circuits, delay in sequential circuits, right? So these are very important topics, like setup and hold time, setup and hold time violation. Okay, how can you rescue from them? Counters, Boolean algebra. Okay, all these things are very basics. Okay, and one more topic is there, that is FSM. Okay, finite state machine. And this is the hardware SDL, okay, programming language. So for electronics people, they have to learn this very log. Okay, so the very basics, but don't worry about anything these topics. Just I have mentioned. Okay, what I will suggest, you have to follow that, right? Okay. So the next is gonna be what is the basic electrical circuit to be focused? Okay, so can somebody suggest me, or in this group they might be familiar with, they might have searched what are the electrical circuits where we need to focus, where TI is going to ask questions, or going to ask questions in the written. Yeah, so I welcome everyone to, yeah. Gaurav Agrawal is saying RC, great, yes. Sanjay, yes, RC circuits, great. Yeah. So the very first, yeah, so everyone is suggesting me that the RC circuit, yeah. So it is very, very important to know that, okay, TI will be always focusing on the very first question, in fact, in the interview, right? In the interview will be the RC circuit, okay, RC circuit, from the RC circuit. And the RC circuit is very, it is also known as what, the STC, okay. STC, everyone is familiar with STC, single time constant, right? They will be putting one resistance here, one capacitance, and they will be directly uh, uh, giving you this kind of a question, and they will give some input here, okay, at t equal to 0, and they will ask you, can you draw the output waveform, okay, by inspection, okay, by inspection you have to draw, by inspection you have to draw, right? So this is all about interview, what kind of question they will be asking about in the interview. But in the written examination, they will be asking, you know, what topics we have mentioned here, right? Let me get back, okay? So the basic electric circuit means they will be always asking from the RC circuits, okay? RLC circuits you can say, and okay, and op-amp questions will be asked, MOSFET, okay, and BJT they might ask by clubbing op-amp and BJT. So I will be talking about what kind of questions they will be asking, don't worry. So prior to that, just motivation I'm giving you. So the very first question they will be asking in the interview, right? So what you guys will do, what, where you guys are going to make mistakes. See, this is R and this is C, okay? So they will ask you to draw the waveform, okay? So you might have seen some YouTube channel or any lecture, right? Some gate tutor is teaching, and you will directly go by t equal to 0 or t equal to infinite or kind of thing, and then you will solve some differential equation, then you will draw this waveform, right? But suppose this is t equal to 0, but they are asking what, by inspection or intuitively you have to analyze this circuit, okay? So intuitively you have to analyze this circuit. So how you're going to draw this, okay? So if somebody will be able to draw this by intuition or by just by inspection, so they will be happy, right? So what kind of question they might ask from this circuit? So can somebody suggest what kind of question they might ask from this circuit? Yeah. And the very first question is what, output waveform. Suppose you have drawn the output waveform, because we are, yeah, transfer function. Uh, see, yeah, pole 0, great. So you are in Laplace domain, yes. Time constant, and yeah, this guy is familiar. Yes, time constant, yeah. Gaurav Agrawal is completely toward frequency domain, okay? But it's okay, yeah. See, uh, we are, we have seen my various lectures, okay? And most of the time, many people solve this kind of a question with the help of frequency response, right? First, what they do is, this is conventional method, okay? Conventional method. See, this is also good, okay? Like, suppose you are writing any bank exam, okay, and there are some questions, okay? And if you're doing 222 into 11, like this, okay, okay, you will get the answer, but somebody is able to directly add, okay, and get the answer. So that is the right way of solving, but answer you're getting both, okay? So the conventional method might consume a lot of time, okay? So Gaurav is saying that first we need to find the transfer function, then we will put some s value, and we will take some, you know, inverse Laplace transform, then we will draw the output waveform. So that will take around half an hour, right? From the moment you start answering, they will start, yeah, and they will help you if you will follow the by inspection technique. Okay, today I will be also letting you know that any amplifier is given. So you have to suppose any MOSFET amplifier or a bipolar junction transistor amplifier is given. So they will ask you to find direct. Can you tell me the gain of this transistor? Okay, gain of this amplifier. So you guys will, what you guys will do? You guys will directly by considering step response. Okay, yes. Right, Gaurav Agrawal is saying something. So you can speak, Gaurav, so that it will be better for me to listen. Yeah,
Yes, sir, am I audible?
yeah, you are audible perfectly.
Sir,
Yes.
what I am saying is basically transfer function I was saying is capacitor can be written as 1 by SC in Laplace domain.
Acha.
And the step response at t is equal to 0, from 0 to pi there's a sudden change. So we
Mm-hmm.
can consider that as a infinite frequency time
Okay.
wave. So S
Mm.
is infinite, so it becomes 0, hence capacitor will short circuit initially.
Yes,
And
that
then
is the,
afterwards,
yeah, it is, yeah, great, great,
and
yeah.
then it becomes an open circuit. So intuitively we
Yes.
can directly get the waveform, and this is a low pass circuit.
Yeah. Okay, great. Yeah, it is a low pass circuit, right? So now, okay, now you have said low pass circuit, right? They are asking question only what is the waveform of this output waveform of this circuit, right? So if you will speak something more, if see, they did not ask about what kind of circuit is this, right? Or what is the nature of the circuit, what are the application of this circuit, right? So if you will speak additional informations, then they might take you what is low pass filter, right? Then you will get into the loop, right? Okay. So the catch here is somebody has in fact told me the by inspection technique. Okay. So once you will draw the waveform, once you will draw the waveform, okay, so suppose the waveform is gonna be like this. I mean, just waveform you have to draw, okay, 5 volt. So initially you have to tell that in the time domain only you have to tell, okay, you have to tell them in the time domain, not like conventional method you have seen somewhere transfer function you have to find. I mean, converting them into Laplace domain, then okay. So initially you have to tell that how capacitor starts charging, okay. So how capacitor start charging after t equal to 0? So you know that how capacitor start charging, right? When current will flow into through the capacitor, yes. So what shall be the initial slope of this capacitor, right? I mean, what shall be the initial slope of this waveform, okay? So you have to first find the waveform, initial slope of the waveform, right? Okay, and then gradually things will go. Okay, so this is how we draw the output waveform of this circuit, right? So you have to tell all these things. So initial slope is the first step where you have to start, right? So I'm not telling you any method, just I'm telling you this is the right way to tell anyone. Okay, where you are going to make mistake is like transfer function. This is also correct. Yeah, they will accept because you are in B Tech and you are familiar with this only, like transfer function, then take the Laplace transform this, convert them into Laplace domain, and then draw all these things, right? But if you want to analyze this circuit with the help of time domain only, so please make sure, okay, these things should be followed, okay. So I'm not going to discuss particular method, just I'm telling you कि directly you have to draw the waveform without taking the help of LTA or kind of so initial slope is the first question they will be posing, initial slope. Okay. And what are the initial condition here? Yeah, so initial slope, how you can determine the initial slope of this waveform? Okay, so these things are very important, right? Yeah, so these things will be asked, right? So yeah, and next will be the few there are few important questions more, like suppose they have asked this kind of a question, right, and you have answered. Okay. Further, they will connect one more RC circuit. Okay, and they will ask what? Again, they will ask question, right? What can be the output waveform of this kind of a circuit, right? So you have to be ready in the time domain only. They will not ask you to describe everything, right? You have to tell direct the output waveform. Okay, and a few more questions will be there. So basically they will be asking questions from RC circuit. Okay, RC, RLC, whatever they can ask, but make sure that you prepare for RC, RLC, okay, RL kind of a circuit, right? Because everyone knows about theorems. Okay, everyone knows about everything, right? KCL, KVL, Ohm's law. Okay, so they might ask a few different questions as well. So suppose this is a capacitor, this is a capacitor, right? And there is a resistance connected to it, and they might ask question, what is the output here? I mean, okay, some input is given, step input again, right? So C1 and C2, and this is R. Hmm? So my question will be, can we apply the KCL at this point? Anyone? Uh, uh, Everyone is here, so can we apply KCL at this point, this node? Yes, anyone from this session, anyone can tell by looking at this circuit? This will be the first question we can say. Okay, so can we apply KCL at this point? Anyone? Right. And they might ask question, what shall be the voltage across C2, what shall be the voltage across C1? Okay, Siva is saying yes. Okay, great. Hmm. So you have to analyze whether we can apply KCL or not. See, KCL, where we can apply KCL? The KCL can be applied where the current, I mean, the KCL is not violated, right? Because of impulse current. Yes, great. Somebody is saying, so remember always, if step is applied here, right, t equal to 0, okay, so you can understand, right? So if you want to charge this capacitor, okay, fully, okay, so you need impulse current kind of a current, right? So very high current, if there is high current, and but here, some finite current is flowing. So yeah, captures are sorted, right? Yes, yes. So suppose somebody is going to ask you what can be the output waveform. Okay, so you have to directly explain. Okay, so what shall be, I think yes, KCL rule is valid everywhere, but yeah, great. So see, so they will be asking output waveform. So you have to explain what shall be the initial slope. So by looking at this question, can somebody comment on the initial slope of the waveform? Initial slope. Yes. So guys, initial slope you have to determine, right? So, and how, what kind of waveform is gonna be. So here the waveform will be looking like this. Okay, the initial slope will be infinite, you can see. Okay, and things will go like this. Okay. So remember, I'm not telling you the method how these things are, just I'm motivating you, right? So in this session, just to make you familiar that what kind of question they will be asking from the session in the interview, right? So RC circuit is one of the very important thing, okay, where initial slope and all these things they will be asking, and they will ask you what is the initial can you find the initial condition. So you can note down the initial condition, okay, initial conditions, okay, I mean on this capacitor, so initial voltage, and they might ask the initial slope. Okay, and you have to justify, you can apply your concept and whatever you want to apply over there. Okay, so in the RC circuit, basically they will be asking what, As I told you that from the transient they will be asking about initial conditions, initial slope, okay, and you have to analyze in front of them, okay. You don't have to solve differential equation or kind of a thing, right? Okay. And other topic you don't expect to be asked, okay, don't ask a thing like that. They will be asking about Thevenin theorem or kind of a thing, okay. So we'll take various questions in the in future sessions. Only this session is related to the motivating you, or what kind of question they will be asking, and and the what are the steps involved in the hiring process, right? And what are the ways you can get into TI, okay. So what in analog circuit to be focused? Anyone, can somebody tell me what are the topic they will be asking? And I will be asking also few questions from you guys. So there are various topics, okay, and you must know the drawback of each topic, okay, why those topics are not being asked. In fact, in the gate examination, those topics are not being asked from past, you can say 5 years, right? Or you can say 4 years. In fact, from the in the gate examination also those topics are not being asked, such as bipolar junction transistor. Okay, so can somebody tell me what is the main drawback of bipolar junction transistor? Anyone uh, from this panel? Yeah, let me choose someone name and yeah. So Himani, can you tell Sanjay? Okay, Pralay, there are various guys. Okay, so why BJT is not okay, is taken into consider nowadays in the industry? What is the main reason? What is the drawback of BJT? See, in analog circuit, in the written examination also, you know, they will be asking questions from op-amp basically. Size, sir. Okay, Siva is saying size, right? Aman is saying losses due to low switching frequency. What is the basic drawback? These are the very high level thing you are telling, right? I mean, yeah, IB current not equal to zero. Great. Yes, somebody is very close to current zero in MOSFET. Yeah. See, guys, I will be telling you the main reason. See, the bipolar junction is basically a bad transistor because of one guy. This guy. Everyone knows this guy, right? The bipolar junction is this so bad, right? Beta is one of the very bad parameter, okay, which makes the bipolar junction transistor bad, right? Why? Because beta is so sensitive with the temperature, with various physical okay, so it varies anytime, it can vary, okay. So you know that the collector current is directly dependent upon beta, and if you're not able to design transistor independent of beta, so that transistor will be bad, right? So that is one reason, and many reason people have given size and everything. Yes, okay. So op-amp will be the main topic where question will be framed, okay. So they might bring diode as well, okay. They might bring diode as well. They might connect diode plus op-amp, okay. See, so what was the main reason they are connecting diode plus op-amp? Can somebody tell me what problem was there in diode? So they are connecting diode plus op-amp, and you're getting new kind of application, right? And what advantage you are getting over there? Yes. So anybody, what problem is associated with diode? I'm talking about any semiconductor diode, you can say, or any ideal diode. Okay. Yes. Clamping circuit. Okay, clamping the circuit. What is the meaning of this? Clamping the circuit. How can we clamp the circuit, right? We cannot clamp the circuit, right? We can clamp the input waveform. We can clamp the output waveform, yes. So what was the main reason? See, these things are very, very important. If you're not good at, you must go through all these things, okay? Yeah, control device. Yeah, very, very, yeah, everyone is answering the question, okay? So the main reason, see, diode, if you're trying to make the diode ideal, right, it is not possible to get the ideal diode, right? uh okay, suppose this is ideal diode, right? Ideal diode characteristic IV. I mean, okay, suppose you are sleeping, okay, and you have connected some diode here, right? And there is a well, I mean, some well is there, and you're sleeping, and here the thief is coming, okay. Thief came, enters your door and stolen your money, right? You will not be able to, get up and can save your money or can save your property, right? Why? Because this diode to be on, this diode, practical diode I'm talking, right? This diode needs zero point 0.7 voltage, okay? This diode needs kitna? 0.7 voltage. So it is not ideal, okay? Okay, so to until or unless zero point 0.7 is applied, this diode will not be on, right? But if you will connect op amp in front of diode, so the moment you will go there, okay, near the op amp, so your ring will start ringing, right? So your well will be there, okay, well will be ringing, right? Why? Because the op amp is very high gain amplifier, okay. The open loop gain of the amplifier is infinite, and it has various characteristics, right? So when you connect diode plus op amp, your overall name of the circuit is what, guys? Can somebody tell me? Op amp plus diode means what? Op amp plus diode means what? What is the name of this circuit? This is known as ideal diode, right? Ideal diode. So you will find questions. I think somebody has shared some PDF in the group itself. Okay. So there are various questions based on op amp plus diode. Okay. They have asked in the written examination. So please look them. Okay. Please see those questions. And if you're not able to solve by inspection, get back to me, right? So these are very important information which I'm giving you. So you have to take op amp and you have to connect the diode, right? And if you and name of the circuit will differ, right? It is ideal diode, but if you're connecting diode in front of the op amp, if you can connect diode in the feedback, you can connect diode in front of the op amp, so name will be differing. I mean, the function of the circuit will be differing, okay, varying, but this is the basic thing where people make mistake, okay. Nobody knows, yes. So op amp you have to focus, right? And one more thing in the op amp is they will be asking the sign of the op amp. Sign of the op amp, this is very great question they ask always. Suppose this is kind of a op amp, okay, A and B is there, right? And you can say that there is some voltage here, okay, or you can say some let me connect oh, resistance here, right? And there is resistance, okay, it is connected from here and then it is connected from here, okay. And you can see this kind of a circuit, right? So they might ask question from this as well, right? This is, suppose this is R1, this is R2, and this is R3, and this is R4. So they will ask you what is the sign of the op amp, okay? Under using negative feedback, you can say, right? Negative feedback. Many people have misconception, right? If this feedback is connected to the negative terminal of the op amp, so it becomes negative feedback. There is a negative feedback kind of thing, right? So they will give this kind of a circuit, okay. They will ask you what is the sign of the op amp. So remember always, sign of the op amp does not decide the nature of the feedback, okay. So there is some algorithm to analyze how to find sign of the op amp A and B. A can be positive, okay, or negative. B can be positive or negative. We don't know, right? So we need to find. So in front of them, you have to tell this. In fact, in the written examination also, Nowadays, this kind of questions are asked. So have you seen anyone seen this kind of a question? Yes. Uh, yeah, I speak. Have you seen this kind of a question? Yes, Aman has seen. Great. And any other? See, if you are really passionate about analog, right, you will definitely be seeing this kind of questions, right? So sign of the op amp is one of the very important topic. No, sir, I heard it about. Okay, 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 great. But guys, let me make you sure that if you are not, if you're not familiar with these kind of questions, make sure, see, because you might have seen various lecture. I'm not going to name those lectures, right? Uh, Dominance of feedback decide the actual feedback. Yeah, great. See, many a times you know that in the op amp they will connect from here. Okay, the feedback is connected from here as well as from here as well, right? So you guys are not able to decide what kind of okay sign of the op amp or what kind of feedback is there, right? So because from both the side, feedback is there. Okay, you can see what is feedback basically. Some part of the output you're taking back to the input. That's it. So this is one of the very important question they will be asking, and you have to tell the steps involved, right? That what are the steps to analyze sign of the op amp under negative feedback. Remember, under negative feedback, right? So these are very, very good questions they might ask you, and there are various things they might ask, like they will be asking that can you draw the transconductance amplifier using op amp? So transconductance amplifier, they might ask using op amp, right? So because OTA is one of the very great example of uh, voltage control current source, right? So can you tell me what is the name of this amplifier? Voltage control current source. Anyone? Can somebody tell me what is the input resistance and output resistance of voltage control current source amplifier? Yes. What is the input and output resistance of voltage control current source amplifier? Yes. Anyone? AK, Aman, Amog, Bhavan, Bipro, Sanjay, Siva. There are various guys. Okay. So, no, sure. Okay. You don't know. Great. Rn is infinite. See, there should not be doubt. Okay. There should not be doubt. If you're going for interview, there should not be any doubt. Okay. So, because TI is not that tough interview, right? They might see, I'm just asking from my side. It is not definite that they are going to ask this kind of question, but yes, you should be good at, because these are very basic thing. Okay. If someone is going to ask you, can you draw the VCCS using op amp? Okay. Because in TI, okay, when you will get into TI in the intern, as an intern or as an full-time analog design engineer or digital design engineer, so they will not give you to prepare Maggie or kind of a thing. They will ask you to draw the circuit manually, and then you have to simulate it, and you have to match from your hand, pen and pencil calculation, pen and paper calculation, and simulation as well, right? So that is what the industry requirements. Okay. So these are very basic things. If someone is going to ask you what is the, can you tell me the examples of VC VS? Anyone? Yes. Can somebody tell me the examples of VCVS? Any example of VCVS amplifier? Bode's control, Bode's source amplifier. Examples of Bode's control, Bode's source amplifier, right? So see, you can go through all these things. Basic thing at least you must know, okay? Then only you would be able to solve questions by inspection. Okay, so I will just show you one questions, right? Uh, and try to find the you know gain of that transistor or a small signal gain of this transistor. Okay, so suppose questions are given like this. Okay, just I'm giving you this kind of a question. Okay, simple question I'm giving you. This is Vi and this is V out. Okay, and plus VCC and this is RC. Okay, suppose they will ask you that can you tell me the small signal voltage gain of this amplifier? So can somebody tell me what will be the voltage gain of this amplifier? Okay. Can somebody tell me by looking at this circuit? Minus GM times load. Great. Yes. So yeah, somebody has told me yes without C. So what you guys will do here is you guys will go for small signal analysis because you have seen various lectures. Okay. So and you will start telling. But what I'm going to do here is see. If you look at very closely, as Bipro has told us that the voltage gain of this amplifier will be what? Minus GM times RC, right? This is the end of the story for you. Okay. In the gate exam, if you are preparing, or in the BTech, if you are, this is the end of the story. But what I will do here is I will take this gain further. How I'm going to write this gain? RC by 1 by GM. See, you know the gain is minus GMRC, but I'm going to write like this. Why I have written like this? Because these are the ratio of resistances, these are the ratio of resistances, okay, looking from different terminals, right? So if you might have seen lectures of Razavi or books, you might have referred Razavi or Sedra, okay, Sedra plus Razavi. Right? These books are very, very good books. Okay. So you will find that. Okay. So see, so how I'm going to tell the gain of this amplifier. So I will tell that if you look, eh, um, Gaurav wants to join. Yes. So hi Gaurav, you bent, okay, offline. Anyway, so if you look the resistance looking from this terminal, this is emitter terminal, this is base, this is collector, okay, and I consider that the beta is pretty high, IB 0, all those conditions, okay, you don't have to worry about that. So you will get 1 by GM is the resistance looking from this emitter terminal, right? Okay. And if you see, while calculating the small signal analysis gain, small signal gain, you have to make this guy grounded. So if you look from here to there, toward the ground, what resistance it is offering, this is RC. So minus you have to put here. Why? Because you are connecting input to base and taking output at the, okay, so it will give you 180-degree phase shift, right? So this will be the ratio of resistances, right? So the gain you can calculate by looking by looking at different terminals. Okay. So this is all about bipolar junction transistors. Okay. When beta is high in the question, they will mention beta is high. They will mention or alpha is unity kind of thing. Okay. They will also mention you the VT value. Okay. VT is how much VT? 25 millivolt. Okay. But suppose VT is given 25 millivolt. Okay. So if someone is going to ask you what will be the value of GM, right? GM of the transistor. So you must know directly that what is GM? GM is basically IC by VT, right? So IC is what? IC upon 25 millivolt. So you must know the value like 40 times IC, right? Directly. So that you can get the answer very quickly, right? Because 1 by 25 millivolt is what? 40. Okay. So in the exam you will find all these things. Okay, they will give you so you can calculate questions. In fact, in the gate examination many questions have been asked. They have given IC 1 milliampere, BT 25 milliampere, millivolt. Okay, so GM you can quickly calculate. Okay, so this is how we have to be good at. Okay, so avoid small signal model. Okay, and understand how to find the how to look resistance from these terminals. Okay, if you're going. Okay, so let me ask one more questions here. Okay, just see, these things are given in the book. Okay, these things are given in the book and nobody knows. Okay, so these are my experiences from the written exams, right? In the written exam these are very easy thing. Okay, they ask and you take questions, so, you take time to solve these kind of questions. Okay, this is single transistor. If they will connect, suppose this kind of resistance is connected. Okay, and one resistance RE they have connected, right, and RC, and now VI and V out. Okay, this is VCC. Now can you tell me the gain of this transistor? The gain of the transistor will be what? The gain of the transistor is going to be AV equal to minus, will be definitely there. Now you have to take the ratio of all, right? You see, I'm writing this gain in one line. Okay, so this guy will be grounded, no problem. Okay, what you call it, AC analysis, right? And then if you see resistance from here, so it will be 1 by GM, and if you see resistance from here, it will be 1 by GM plus RE. Okay, so what kind of circuit is this? This is the emitter degenerated circuit, right? Earlier emitter resistance was not there, but now emitter resistance is there, right? So what is the advantage or disadvantage of having RE or not having RE? These things you must know. If RE will come into picture, what problem will be there? Okay, all these things. And so this answer will be what? RC upon 1 by GM plus RE. Any question you can solve, any kind of questions you can solve, right? So you can see here, this is very easy way of finding the gain by without drawing a small signal. But if you look at the YouTube channels where people discuss this that, okay, because basically you rely on YouTube, right? Where many people discuss okay, this kind of, okay, they take this question and they use H parameter. Okay, here might be many students, they might be using H parameter. Guys, let me tell you, H parameter is not used now. Okay, in fact in the exams like gate nobody asks questions from H parameter, right? So in the exam also you will not find questions from H parameter, but don't leave this kind of a topic as well, you must know. But okay, H parameter we don't use, but most of the educator or most of your mentor, they teach H parameter, right, to solve these kind of questions, and you follow them. So at the end of the day, analog circuit becomes very difficult for you. Okay, network is easy, control is easy, signal is easy, right? But in all the subjects there are few topics which are not covered by you. Okay, that's why you feel, oh, everything is easy, right? Everything is easy, but provided you have covered all the topic. So this is what the one approach is to find gain. Okay, they might ask questions to find out the you know, find out the time constant of the op amp. Okay, time constant of the circuit in the op amps, right? Let me ask one more questions, one more basic thing which uh, you guys don't know. You guys only know KVL, KCLs. Okay, yeah. Suppose this is a circuit, right? Suppose this is a diode, and I have connected circuit, uh, capacitor here, and I have replaced the capacitor with the diode, and here you can see this is a circuit. Okay. Now, can you name of these circuits? Okay. Can you name of this circuit? What is the name of this circuit? Anyone? What is the name of this circuit? Oh, clamper. This guy is saying clamper. Guys, note down these things. Okay, Gaurav is saying, GA is saying, is it a clamper? How many of you are agreed with him? Bipro is saying no, right? Oh, Varactor diode. Siva is saying Varactor diode. These are the answers I'm getting, right? Yeah. I'm not telling guys these things, but I'm getting answer. Yes. More? Yes. Amo, can you tell me what is the name of this circuit? Because at the end of the day, we have to clear TI program, right? So at least we must be good at, okay? Clipper. Okay. Clipper. One Bipro has said clipper. Amos said don't know. This is the right answer. Okay. Okay. If you don't know about the name of the circuit, don't start telling, right? Otherwise, your teacher will start. Your interviewer will understand from the day, from the moment you will speak something, and the life is end there, right? I mean, you will get another chance. Okay. There are various ways to get into a TI, but yes. So the main purpose of conducting this session is to let you know that where you are weak at, okay, and where you need the proper guidance on these subjects, right? And my words are always like this: how these subjects are studied, how these problems are solved. See, don't attack into the problem. First identify what kind of circuit is this, why they have connected capacitor and diode. See, somebody has told this is clipper. How can it be clipper circuit? Because clipper needs only diode and resistance, only diode and resistance, nothing else. In the clipper, have you ever seen the capacitance? Okay, so they might connect capacitance, okay, but in case of Aman, okay, there is a question mark, right? Okay, great. It's okay. It's okay. It's okay, right? So see, if you have got two element, okay, two terminal elements such as diode and capacitor, right? So, and one more thing I will tell. See, don't see always if somebody is solving questions, how they are solving questions. Think through that question, right? Okay, then only you will be able to understand. Yeah. So for the written exam, I will tell what are the book you have to follow, what lecture you can follow, so that you can clear the written exam on the college when it will. Please tell the name of what? Yes, someone. What? Can you repeat the question? Yeah, let me open this. Yeah. Please tell the name of this circuit. Yes, I'm going to tell Aman. Yeah, wait. Yes, great. See, suppose we have, yeah, great. Yeah, suppose we have two element. Okay, these are two elements. Okay. See, if I say this is ideal diode, so don't believe on me. Okay. If it is a ideal diode, don't believe on me. Okay, because you know the reason, right? If I connect op amp in front of it, yes, that is going to be diode. So whatever circuit you have studied, diode plus capacitor, diode plus resistance, so you can replace that diode with op amp plus diode. So that name will be same. The functionality of the circuit is not going to be changed, right? Only the nature of the diode is going to be changed. Okay, that diode will become the ideal diode. Okay, so see, depending upon depending upon the way or across which element you are going to measure the output, okay, to measure the output, name of the circuit will vary. Okay, so see, you can connect diode and circuit capacitor like this. You can connect, okay, you can you now you're measuring output across the capacitor, right? And here you are measuring output across where? You are measuring output across the diode, right? So if you are measuring output across the capacitors, so the name of this circuit is going to be the peak detector. Okay. And if you're going to measure the output, see in the question you will be able to see if they are asking output across this diode, so this circuit will be named as clamper circuit. Okay, clamper circuit. Okay, so if question is given, you start analyzing, right? Okay, when we are in positive half cycle, case 1, diode is on, and yeah, it is okay, okay, okay. Answer is this, right? Yeah, but you don't know what is the name of the circuit, right? See, always focus where they are asking you to calculate the output, okay, across which element they are asking. So this will be the peak detector. This is going to be the clamper, right? To so everyone understood that how we can name of this circuit. Yes, great, very good. So now I'm able to see your chat. Earlier I was not circuit with diode, and yeah. So guys, you might be feeling that this is full of technical session, right? Okay. So this is how we go. Okay, always. Okay, this is how anyone should talk. Okay. So see, if you have only diode and resistance, so across any element you measure the diode output, you will always get the single name. That name will be the clipper, right? So in case of clipper circuit, okay, in case of clipper circuit, suppose this is diode and this is resistance. So now you are measuring output across this resistor. So name of the circuit will be clipper. And if you are measuring output across the diode, but there is no capacitance, so still its name is same, clipper only. Now there are different kind of clipper, whether you want to cut the positive portion of the waveform, whether you want to cut the negative portion of the waveform, what portion, what part of the waveform you want to cut, okay, from the input waveform, that kind of a circuit you have to design. Okay, so basically, see, this is perfect. Case 1, case 2, okay, case 3, this is semester, right? In the semester we write all these things. Okay, in IES you have to write all these things, but in gate or in okay, and you must also know that what is the main condition, what is the main condition, the important condition is associated with this clamper circuit. Can somebody tell me what is the important condition associated with this clamper circuit? Anyone who is present in this session? Yes. Yes, anyone? So let me check the comments. Hmm. So one more question I would like to ask, okay, that can we see the Miller effect in CV or CC? Can we see Miller effect in CV or CC, or can we see Miller effect in case of non-inverting amplifier, non-inverting op amp, you can say? Okay. So these are very easy question. They test your basics, right? So these things are very important. What is the importance of Miller effect? Okay, because there will be capacitance, there will be resistance. Oh, in non, okay, okay, wait. Somebody is saying yes. So guys, you have to justify it. So can you, who has answered? Gaurav Agrawal. Yeah, Gaurav Agrawal, can you answer? Just unmute and answer me why. Okay. So guys, after this,
So,
uh,
basically in a non-inverting amplifier,
yeah.
uh, basically the feedback element which we have,
Mhm.
if we see from the node like the feedback node from the input side, there I can apply the Miller's theorem and I can state R by 1 minus A, like the voltage gain across that 2 points, the output and the input, where the feedback is present.
Okay. Yes.
But the only issue in non-inverting cases that the feedback is positive feedback. Sorry, the negative feedback. Yeah. The only issue what we do is we take out the A as the gain of the amplifier, but it's actually not the gain. It is the difference between the output node and the input node of
Mhm.
the feedback element.
Acha, great. So guys, see how Gaurav is answering, right? Okay, based on his expertise. So let me inform everyone, and you have to also find out these reasons, okay? That Miller effect cannot be seen in non-inverting op amps. It can only be seen in inverting op amps, right? Okay, and in common base and common collector also you cannot see the Miller effect over there. Your common base and common collector do not suffer from the Miller effect. Your common emitter suffers from the Miller effect, remember, okay, suffers from the Miller effect, right? So these things are very important, and you need to find out the answers as well. When I have taken sessions everywhere, I have seen. Okay, so I know you are good at circuits, right? You are good at KVL Ohm's law. Okay, but please make sure analog should be also good, right? Analog should be also good. So uh, uh, everyone must know that how many types of amplifiers are there. So can somebody tell me how many types of amplifiers are there?
So four types.
Okay, how you decide there are four kind of amplifiers?
So basically voltage, current, transconductance, and transimpedance.
मतलब how you decide there are four kind of amplifier? I mean, what exactly you see? What is the
So
need?
looking at the characteristics, like we get the current gain or the voltage gain, some like that.
Acha. Yes. So yeah, your answer is somewhat very close to okay, but yeah, there are various information you can tell. Okay, see, in electrical engineering there are two kind of quantities only. One is voltage, one is current. So after all, you are applying those input to be amplified. Okay, because your input is at very low strength. Okay, so you can apply either voltage or current and it will get amplified. Okay, so in the output also you can get voltage or current, right? So there are two quantities in input, two quantities in output. So in this manner four kind of amplifier you can realize, or you can also tell depending upon the input and output resistances, right? Because each amplifier will be having their own input resistance and their own output resistance. So you, how you are deciding whether voltage source has input resistance high, output resistance low, and you must also know some range of those input resistance, output resistance, and you must also know the examples of these. So can somebody tell me what is the best example for voltage control voltage source? Best example, yeah, anyone?
Sir, op-amp.
Yeah, op amp is one of the versatile. Yes, great. Other guys are not letting me know these things. Yeah. So op amp, and there are various like VCCS. What are the examples? And my question was how to draw the transconductance amplifier using op amp. How to draw transconductance amplifier using BJT and MOSFET, all those things, right? So please, guys, at least you must know how to find the gain of the amplifier, okay, directly. And you can also draw the small signal because you have to clear the written exam. So but in the interview, please try to see the question and try to explain them, okay, in a natural way, okay. There should be sanity check, okay. Okay, you know these things, you know basics, okay. So please make sure all those things, right? So in the MOSFET, one of the very important topic will be asked in the exam, the MOSFET, right? So in MOSFET, they will connect various transistors, okay, and they will be asking questions from there. So I'm just giving you one very easy, okay, the way you calculated, this is VDD, okay, and this is input here, and this is output, right? And this is RC. Sorry, RD, right? Yeah. So now they will ask you what is the gain of this, okay? So here they have connected only one transistor, but in the examination they will connect various transistors, right? But make sure that across which transistor the input is applied and output is taken, okay, that transistor will be deciding the gain of overall transistor. Remember this point always, okay. Okay, you have to see always the input resistance from this, and you have to see the resistance from this node to other circuit part of the circuit, right? So for this it will be 1 by gm. This is the gm of the MOSFET, and here it will be RD. So the gain of this transistor will be minus RD upon 1 by GM. And now you will say, sir, I know only this GMRD. Yeah, this is correct. It is written in the book, but please know how to write this. So gains, you can, you can solve any questions in seconds, okay? By looking at the circuit, no matter how many transistors are connected, okay, you can analyze, okay, you go from here to here, okay, what current is flowing through this, okay, and how you can write the gain and all, you must know, please. And if you are going to degenerate this guy, connect areas, so how this RS is going to affect the gain. So guys, can somebody tell me if RE is introduced, emitter resistance is introduced, so what kind of gain will increase or decrease? Yes, anyone? Decrease. Yeah, someone is saying decrease. Wonderful, yes. So guys, you have seen also the mathematical formulation I have told you, okay. So how many of you are here who are interested in pure analog circuit design? Pure analog circuit design. Okay, Bipro, more guys. Amog, yes. Or because analog is one of the very interesting, yes. Let me check hmm, your yes. Hmm. So other guys like there are various okay students are here. Siva, Himani, Gaurav, Bipro, Bhavan, Amog, Aman, AK, right? Okay. So guys, if you are interested in analog circuits, so as I told you that it is very essential to know about signal and system as well. Remember, signal and system, some basics. Okay. Signal system. Why we want to know signal system? Because there are few topics such as uh, Fourier series, Fourier transforms, okay, because most of the time you will be dealing the circuit in case of analog circuit, okay, most of the time there will be capacitance, okay, so the frequency response, high frequency, low frequency, and you have to plot the Bode plot as well, okay. So Bode plot is given in control system, right? So control system is also one of the very important thing, and this guy cannot be ignored, right? Maths, where maths must be like calculus, you must be good at calculus, okay? Because now I'm asking about initial slope. What is the meaning of initial slope? Slope is basically the differentiation. Understand? So you must be good at calculus, right? Engineering maths is very, very important. Okay. So Bode plot, signal and system, in signal system, Fourier transform and Fourier series. Okay, you must be good at what is Fourier series, what is the use of Fourier series, how you can transform from time domain to frequency domain, all these things, right? Bode plot, what is the need of Bode plot? In case of amplifiers, in case of analog circuit, yes. Anyone? Have you seen Bode plot in analog? Anywhere Bode plot is drawn? Yes. Yeah, frequency response, great. Mhm. Yes. Mm. Filter, great. So Bode plots and all are very important. See, the main reason is that the gains are having very high values like 10 to the power 6 or 10 to the suppose 10,000 you are getting kind of thing, right? So if you're going to take the log of this, okay, so this value will be compressed, right? So you can easily plot the 20 log something, okay, 20 log AV, and this is how something will be looking like, and you can decide the cutoff frequencies and all those things, right? And you can also easily tell the characteristic of the nature of the circuit. One guy in the beginning told me that that circuit is low pass or high pass, okay. So by drawing this Bode plot, at least name of the Bode plot, right? But you must be good at basics of the Bode plot. See, if you see good lectures, right? Let me refer some lectures. So you can see lectures. Just I'm writing here. I will be talking bit. Here I'm just writing. So you can see there are one lecture is there on YouTube. Jele, okay. Rajesh Jele, Rajesh Jele, Professor Rajesh Jele, something name is there. IIT Bombay, right? In the pandemic, he was teaching analog circuit, right? Have you heard about Rajesh Jele? Anyone? IIT Bombay professor, Professor IIT Bombay, right? He worked at Qualcomm, he worked at various institutes, and now he's a professor, not institute, he worked in various companies in US, okay, and he designed various circuits, right? But now he's full-time professor at IIT Bombay. So in the pandemic, he was teaching analog circuit for BTech students. So he used to upload pandemic in the sense just 2020, you can say, right? 19, 20, 21, 2 years back, right? So in the YouTube, it is uploaded few lectures. So you can get an idea how he starts, okay? Uh, so you will get to know the basic thing, what is the prerequisite to learn analog circuit, right? Prerequisite, how you have to think, what should be the thought process, okay? So do refer these lectures, right? Everyone prefers Razabi. Yes, Razabi is good, but we are like if you want to refer some IIT's lectures, so it will be far better, right? And one more suggestion to be good at basic electrical circuit is electrical circuit, right? Because you have your exam, suppose you have your exam tomorrow or after 1 week, so we cannot conduct the class here, right? But if you will be joining us or in future the course at IGC for gate and all, so these things will be taught, definitely basic electrical circuits and analog. But to prepare, these are the material I'm referring, okay, because they will be also great in length, right? I don't know whether you will be able to understand, but yes, for BTech students who are not preparing for GATE directly getting into, I mean, going for TI, so they can refer all these things, some basics lecture, right, by Professor Nagendra, okay, Nagendra Krishnapura, right? Have you heard this name, Professor Nagendra Krishnapura? Yeah. So, as well as one of the great name, Professor Pawan Shanti. Okay, he is also in touch with me on WhatsApp, right? Okay, once upon a time, he took my interview as well, right? Okay, so it was a great experience. Now we are in WhatsApp as well. Okay, so yeah. So this is very important information. Like in India, there are two professors only who teaches analog and basic electrical circuit nicely. There are various professors, but yeah, they are good at. Okay, so you must at least look at this. Okay, so okay, so one of the very important question is there, which is being hidden here because I have written on top of that something. Okay. So that question, let me highlight here, is that this question is a very important question. Okay. So guys, TI looks for analog. Okay. TI look for digital profile as well, right? As I mentioned digital. So I will be discussing about digital as well. Don't worry. Okay. What is the time? 10:22. So okay, within 10 minutes or 15 minutes, I will take your time. Then we'll end the session, right? And for 5 minutes, you can ask questions also, any doubt. I mean, not related to your subject, in general doubt, right? How Cambian tea, who is saying, what is Cambian tea? I did not understand. Gaurav Agrawal to everyone. What you are asking, I did not understand. Cambian tea is like, I did not hear about it, but yes. Anyway, we will take your doubt at the end. So, what are the ways to get into Texas Instrument into India? Okay, so first of all, you can get into Texas by if that company is visiting you, so they might hire for the intern, right? So for the intern, as I told you, the basic needs is they will conduct interview, written and interview. Okay, it's not like any recommendation will be there. Okay, and they will come for full-time role as well as interview, right? Full-time role as well they will come, and they will come for the intern, and process will be same more or less. Okay. Ha. If you will go for intern, so you might get the PPO as well, full-time role. Okay, one of the student was there from Kerala. Okay, he was from Kerala and he took my guidance mock. Okay, uh, he took my guidance and he cracked his name. I forgot his name, has kind of name because different names are there. So he cracked. He said that he got some 15 LPA. Okay, as a base. I mean the package over there, because he is just a BTech student. So 15 LPA he got right initially, and some basic was there 9 or something. Okay, 9 LPA. Some this is the another part of that, but you must be good at analog first, right? And basic circuits. LPA is different thing, right? So that guy got selected. He was from Tier 3 college only, not Texas or something. Not from an IT. So it is of 33 lakh in our campus. Yes, sometimes yeah it offers yeah great because see which college you are telling? Can you II, yes, which college, Gaurav? Oh, IIEST Sipur, yes, manage Jaipur. Yeah, definitely, yes. Because from there are various friends of mine, they are working at analog from this college. But they have one approach was there, like if you are able to get good rank in gate exams, right? Suppose somebody is preparing for gate and they fail to crack these TI in the college. So if they might go for Texas Instrument program, okay, conducted by IIT Madras only, right? So you can get into TI then, right? They will offer full-time job, okay? They will give you 2 years intern, and you will be pursuing degree from MS from IIT as an MS. okay, under Pawan Santi and Professor Pawan Santi and Professor Nagendra Krishnapura, right? And you can get into TI as well. So they might, okay, there are various friends of mine. They are from IIST, okay. I mean, IIST Sipur, right? Yeah, Manit, definitely you are from NIT. So in NIT, the package will be like that. I'm talking in general, the average package, right? Because now that parameters varies, right? So guys, be good at analog and digital. So the reference I have told you, the book which you have to refer is Sadra and Smith. Okay, and you can refer Razavi as one of the book is there, Razavi. But don't think that they will be asking questions from very big questions or very tough question. They will ask very easy question. Okay, RC circuits, how to calculate time constant of the circuit, how to calculate bandwidth. Okay, and they might ask questions uh, from op amps, right? How to find the sign of the op amp. Okay, in the written exam as well. So I will suggest a couple of PDF is shared in IGC platform in the Diode group, so you can take those PDF and mm, you can basically check what kind of question they are asking, right? So I would recommend for GATE as well, if somebody is preparing for a campus, it's okay. But if they are not good at analog, still they want to get into TI, so they might prepare for GATE. GATE GATE score less than this time. GATE score was less than 360, 350. Sorry, 650 or 700 around. GATE score I'm talking, not the rank. Okay, so this is the requirement, okay, for getting a call from IIT Madras. And your interview will be, your written exam will be there, and question will be asked from the written exam. And in fact, AIR 1, sir, will you take our mock interview? Aman, certainly you can get in touch with uh, sir, okay. You can get in touch with sir and you might ask to him whatever requirements you have, then he will inform me, then I can conduct one-to-one mock exam, I mean mock interview, right? So if you will pass in the mock interview, so definitely you will pass in the final interview. This is 100% because this is tested, okay? So mock interview, yes, yeah. So for the mock interview, what is there? See, suppose if you are not able to answer any question, so I'm going to tell you, okay, this question can be answered like this. So in the exam, main interview, they will also help you to answer the question. Don't think that they will not help. But yes, you don't have to talk about many things. If they are asking this, so you have to answer this. Don't talk about low pass. Don't talk about high pass. Don't talk about Bode plot. Okay. Uh, I mean, gradually wait for. Sir, I have Texas Instrument intern test on 24th July. Please suggest me some tips. Yeah. Yes, Gaurav, I'm going to suggest. So these are the ways. And somebody, if directly want to apply Tier 2 college or Tier 3 college, they can visit Career TI, okay, and they can apply there. Okay, so they might get some call if their resume is good, okay, because after all you will be working on analog, so you will be designing ADC, DAC, okay, all these things for industrial application purposes. So uh, using op amps, right? So you can apply directly, and you can also look for LinkedIn profiles, right? Where you can ask recommendation. Okay, if you're really good at circuits and analog, guys, don't message anyone. If you're not good at, circuits and analog, I mean, some basic things you don't know. Okay, still you have to brush up. So don't message anyone, right? If you're good at, message them, ki sir, can you refer me? And okay, I want to work there. So they might look at your resume, and yeah. So there should be some words like analog and all in the resume. If these words are not there and you are sending resume simple career, aspiring for this company, and these are my marks, okay, no projects, Okay, so guys, and tools and all not there, so they will, right? So at least interested in analog and mention all those things. Okay, and if you know truly, but if college on campus, it is easy to get into, right? And off campus, yeah, it is also easy, but you need to, make connections on LinkedIn and various, right? Okay. So this is what I wanted to discuss. And one more thing was there. What are the things you need to be focusing on digital profile, right? So anyone is here for digital in Texas? Anyone? So I will not cover this topic then if nobody is there, right? Anyone is here who is interested in digital profile? Can I check? Oh, yep. Nobody is there, I guess. Yeah. Hmm. It's okay. Nobody is there. So yeah, but in digital, mostly, let me tell you guys, very important thing, okay, where you have to focus. You have to focus on delay in combinational circuits, okay, delay basically based on delay in comb as well as sequential, right? In both the, okay, and you have to be good at counters, flip-flops, okay, latches. Someone is asking, how can I reach you for the interview? As I told you that this session is being conducted on the IGC platform, right? So you can directly get in touch with, Dinesh sir, right? And you can ask everything. So we will create one Google form. I will suggest Dinesh sir to create one Google form over there, and you can fill that Google form, and then we will plan for the timings. Okay, because basic information we need such that we can mail you for, or we can directly contact you for your mock, right? So better way to connect is connect with Dinesh sir, and he will let us know, right? It's okay. So delaying combinational circuit is very important, right? And I can give you also some number if I'm having. So or else you can directly get in touch in the Telegram. Okay, just write in the post as a in the Telegram, sir. How can we connect in the for the mock interviews? So sir will guide. Okay. So delay in combination sequences, setup and hold time violations, finite state machines. In fact, these topics are also asked in GATE exam, right, nowadays. They don't ask questions from very easy topics, right? Yeah. So these things I wanted to discuss today. And let me, the end of the session here is, okay. Yes. So now what I will do here is I will take your doubts. I mean, general doubts, not, okay. So you might be thinking, sir did not talk about how to get a call from TI and how to get all these things. I have talked, right? I have told you the ways to get into TI. So gate is one of the very important step, right? Where you can, you know, get good package. Okay, if that company is not visiting to your college, because this company does not visit all the college, right? Some of the college they visit IIST, yeah, Manit and some NITs, in fact, top NITs like Surat Kal. So all the VLSI professional, I mean, MTech student, they get placed here. Yes. So guys, now open to your doubt. Yes, please. Yes, yes, definitely. This college, what you mentioned, like BJTI and everything. Mm. So I'm open to your doubt. If you have any doubt, you ask. Yeah. Unmute and ask, then I will answer you. Yeah. Or else you can write as well. Yes. Any doubt in entire session? See, aptitude syllabus is same as CAT syllabus. You can copy and just prepare all the topics in aptitude. be it reasoning, be it permutation, combination, basic probabilities, okay, number system, okay, and time and distance problem. Okay, yeah. Next. And in analog, I have told you MOSFET, op-amps, and in BJT there and MOSFETs and amplifier, there are various things like differential amplifier. Okay, so I did not talk about those things like Darlington pair, how you are going to model them. So all the topics you have to cover. So basically four kind of amplifier, and plus three kinds of configurations. Okay, you must be good at. Four kind of amplifier means what? Four kind of amplifier and three kinds of configuration. So VC, VS, CC, CS, all those things. And here digital, any YouTube channel for digital. See, there is no YouTube channel anywhere. The contents are being taught in the good manner. Okay. I haven't found till now like for any sorry. Okay. There are good channels where digitals are taught. Okay, so you can get in touch with me if I will find any YouTube channel, okay, where you can get good information related to digital like FSM and all. But make sure that if you first of all you need to clear theory from this, okay, then problem solving. Who is asking about Gaurav Agrawal? Yes. So Gaurav, what you can do here is you can revise basics of RC circuits. Okay. You can solve gate problems, gate PYQ, right? You can solve gate problems, right? And yeah, I mean all the questions given in gate like op amps, you might be having some previous year questions. You can download from the gate portal, okay, gate websites. You can try questions, okay. One of the question I can give you, in fact, if you want. Suppose one question is given, okay, this is minus plus and this is okay, and this is a very easy question I'm giving you, 31k 1k, okay, and this is 1 volt here, and this is plus 12 and this is minus 12, okay, and V out. So what is the value of this point VA? So can somebody tell me what is the value of VA? You have to find the value of VA, and op amp is ideal, everything, right? Very easy question, right? It is just a gate problem only. Just I'm giving you, right? So you have to find the potential at this node. So who has answered VA0? Gaurav Agrawal is saying op amp is ideal, and you have to answer somebody. Shiva is answering 0. Somebody has, yeah. Gaurav Agrawal, you are changing your answer now. Earlier you said 0 and now you're telling minus 2. Great. So guys, don't attack directly into the problem. Yes. Okay, great. So you must also know that where the virtual ground is the concept is valid, okay? And you must, how you can make sure that there is a virtual ground concept fail? These are the resistances. See the resistance values, okay? They are very huge, okay? They are very huge. Definitely this op amp will be saturated. So don't be blind, right? Directly answering the question. So just check these resistances connected across. Okay, guys. Uh, oh, VA0. Okay. Gaurav Agrawal is saying VA0. I'm asking about VA, man. I'm not asking about minus 12. My question was VA only. Okay, so how it can be 0, Gaurav Agrawal, right? So here you have made mistake, right? So in the answer, in the options, answer will be yes, 0 also. Okay. So please make sure that yes, these things are very important. Okay. So find out VA here. Right? I'm not going to tell you the answers for these kind of questions. You have to analyze yourself, right? Just I'm giving you the, I mean, just some tips, right? So Gaurav, you can do like you can brush up the basics first, right? And be confident. -12 by 32. Who is answering here? Aman is answering yes. Yeah, you can solve questions by KVL and all. Guys, you can take the screenshot of this and share your answer in the group. Okay. So better, many people will be discussing. Okay. So please take this problem and answer in the group. Okay. I don't know whether this problem is correct, but still you can take. Okay. And enjoy. Okay. This is +12. This is -12. In fact, you can take 15 as well. I don't have any problem, right? Right. Okay. So, Gaurav, you have to do what? You have to brush up basics of aptitude also you can go through so that you can solve questions quickly and the basics should be very strong. So, read RC circuit, talk about RLC circuit and some pole zero plots, what you have said in the beginning, right? And undamped, damped, all those things. Okay, how to calculate pole zero frequencies, how to calculate bandwidth and all. Okay, so everything you take down, right? And the way I told you to analyze. Okay, in fact, for everyone, solve gate problem to clear written exam. If you are not able to solve gate problem, then there is a problem, right? So if you will be able to solve gate questions, definitely you will be able to crack Texas instrument written exam. Okay, so solve all the problem given in op-amps, solve all the problem given in BJT, MOSFET, diodes. Okay, it will take only 2 days. Okay, yeah, great. Wipro is answering great. Yeah, yes, very good. So I don't know the answer. I did not calculate whatever answer you're calculating. Just you should give me the final result. But yes, the way you might be calculating, I don't know, right? But yes, make sure that sorry, this is yeah, next page. So make sure that this is very very important, right? So look at the resistances. Yes, Wipro is, yeah, by super. So you see, after all, this op-amp has got saturated, so virtual ground concept fails. And here you have to apply superposition, right? And VA can be evaluated easily because output will be -12 always. Yes. Great. After all, this behaves like a comparator circuit, right? It is not behaving like a, uh, uh, you know, this behaves like a comparator. Okay, directly you can see. Okay, there are various questions I can give you. So try to look at gate problem. Okay, and you can answer questions. A question or have one of the very good question I can give you here. Let me raise again. This part I want to erase and take down this question and yeah, gate PYQs. Only gate PYQs are enough. And also you can solve questions, two PDFs are shared in group. Okay, so you can solve questions, various questions, I think. So gate problems, if you are able to solve, you can solve any problem, right? And some of the lecture as I suggested you can watch for so bus you need to clear basic electrical circuit, so just watch those lectures, RC circuit, and how professors are talking about that. Okay, but if you need any guidance, short-term guidance, so you can get in touch with Dinesh sir as well. So he might suggest, he might plan classes for you guys. Okay, I don't know. I mean, if you have time, okay, to prepare for all this, so we can conduct classes, some, classes for these topics. Okay. So depending upon your interest, things will go right. So if you have lot of time, if you are in second year, third year, final year, okay, and still company has to come late, so you can join IGC as well, I would suggest, because I'm the part of IGC here, so I guide many students, so you can, okay, whenever time permits me. So yeah, so okay, so this kind of a question is there, like circuits, okay, I'm just giving question, you can solve this kind of question. V out and uh, okay, this is VI. Okay guys, and this is again there is plus 12 and minus 12, you can see, and this is the resistance here. Okay, this you can say this is 3K, and this is 1 microfarad, and what is the output if this kind of a pulse is applied, okay, at t equal to 0 there is 5 volt. Okay, so what is the output at t equal to 0 plus? What is the output at t equal to 0 plus? This is also one very good question, right? Some pulse is applied, okay, you can say 20 microsecond pulse, and 5 volt is the maximum value. So anyone can answer this question? Note down, and this is input here, and you have to answer V out at t equal to 0 plus, right? Answer, what will be the V out? It is a numerical type question, you can say. There should be numerical value. Yeah. Then we will end up the session, guys. Okay. So everyone, make sure that join IGC if that company is not wasting and you have a lot of time, and if you are preparing for GATE, so the subject like analog and devices and these subjects, you will be mastered, and you will get into ISC and TI as well. Many of my students, in fact, this year, Ankur Garg, he joined ISC recently. Okay, he got 32 rank in GATE. So various students are there. I mean, they are. We have been talking about these kind of a concept, but in the YouTube we don't discuss, because if we will discuss all the thing in YouTube's, then uh, you know things will be different, right? So these things we cannot discuss on YouTube, but yes, yeah. So what is the answer for this question? Anyone? Last. This is my doubt only. I'm asking from you, and you can answer. Yes. In the group, you can answer. Take down the question and answer. Okay. Yes. Okay. So Gaurav, as I suggested, what you have to follow, right? And any other question anyone have, do ask me now. Then we will end the session. Among the other sources for solving problem other than gate PYQ. Yes. Aman, yes, there are various sources, okay, but I will suggest ki just focus gate problems, and they will at least give you some flavor, right, for the moment, because you have very near, the company is supposed to, okay, and you can follow IIT Madras integrated circuit and system website, where you will get some questions. Okay, so these things are, yes. Any other, but yeah, for the solution you will have to be good at basics, because these questions which are given in IIT websites are not solvable, because one is not good at basics, right? Yeah. So anyone will the output be impulse? Amog is saying, man, I'm asking that what will be the I mean, what will be the answer in numerical format? Okay, don't tell me the answer in like impulse and all. I'm not asking about the waveform. Okay, I'm asking the value, output value at t equals 0 plus. My question, try to understand the question. And how does this op-amp behaves when you are trying to calculate output at v equal to, I mean, at t equals 0 plus? So yes, these things are very important, guys. So it's okay. I will sum up the session here because it's been couple of hours. This session, I mean, analog is so interesting, and we guys, we all are so passionate about analog. We have a lot of patience, to end this season. Okay, so I will wish all the best for everyone who are going to appear for this exam, okay, and interview, right? So they can get in touch with Dinesh sir and with IGC for the interview preparation. First of all, they prepare for that, and meanwhile, they must keep preparing for mock interview as well, right? And get in touch with IGC. And if you are preparing for GATE, in fact, you can join IGC, okay? Yes, Wipro is a great season. Yeah, my observation from this season, I have to, yeah, definitely you have to work on twice, okay, because in the YouTube channel, you might be following various YouTube channels where people discuss solution of any questions or uh, any session you might have seen, right, where people discuss, big format, big solutions, and you guys get inspired, okay, but that is not the way to get into TI, okay. By mistake people can get into TI, ऐसा नहीं है बहुत सारे लोग हिंदी वाले भी होंगे, राइट? सो ऐसा नहीं है, people can get into TI, but yeah. Okay, so thank you so much, guys. We will end the season here, and do get in touch with me. Thank you so much. Okay, take care and bye bye, and all the best. We will meet in the next season if you would be requiring any season. Thank you. I think nobody was having doubt. That's why I'm ending this season. Okay. Yeah. Thanks.